Hello everyone. This video I'll explain laws of probability. The first law is addition law. Addition law states like this, that SP the sample space A and B are events of that random experiment. A, B are events are nothing but A and B are subsets of S. Then P of A union B equal to P of A plus P of B minus P of A intersection B. P of A union B means probability of the event either A or B, or probability of the event at least one of A or B. I had already explained the terminologies in the previous video. So A union B means either A or B, or at least one of A or B. So P of A union B is given by probability of this either A or B is given by P of A plus P of B minus P of A intersection B. This is called as addition law. So using set theory concept, if you have two sets A and B, this is the whole sample space. Sample space is the universal set. It is represented by rectangle. A and B are subsets. They are nothing but events here in the case of probability. So this circle represents A, this circle represents B. The common region represents A intersection B, means event A and B. This part represents only A, this part represents only B. Now this whole region represents A union B, either A or B. Either A or B means only A, only B, or A and B, both A and B. The region outside this shaded part is called as A union B whole dash, which is nothing but neither A nor B. Hence, we have P probability of A union B whole dash is equal to, from the entire sample space you have to subtract, that is S minus A union B will give you A union B whole dash complement. So its probability is calculated like this: P of A union B whole dash is equal to P of S minus P of A union B, that is equal to P of S. Probability of the sample space is always 1 using the axioms of probability, minus P of A union B. So this is how we calculate P of A union B whole dash. Dash means complement, means not the given event. A union B means either A or B. Whole dash means neither A nor B. So similarly, if the events are mutually exclusive, means they do not have any element in common, separate A and B. So in that case, P of A union B is given by P of A plus P of B. Just these two terms, no P of A intersection B term, because A intersection B, they do not have any element in common, therefore it becomes null set. Probability of null set is 0, so this term vanishes. So this is called as addition law. Let us see what is the application of addition law while solving problems. See the first problem. Find the probability of getting either a number multiple of 3 or a prime number when a fair die is thrown. A die is thrown means sample space is having 6 outcomes: 1, 2, 3, 4, 5, 6. You have to find the probability of getting either a number multiple of 3 or a prime number. So OR comes means it is a union. You have to define two events now. First event A is a number multiple of 3. It's a multiple of 3. Event B is the prime number. Prime number. So you have to find out what is the probability of getting either a number multiple of 3 or prime number. So you have to find out what is P of A union B, multiple of 3 or prime number. So which is equal to, as per addition law, P of A plus P of B minus P of A intersection B. Okay. Now let us find out what is A intersection B. Finding a number or getting a number which is multiple of 3 and prime number. So multiple of 3, it should be multiple of 3 and it should be a prime number. Such numbers you have to find out. That gives A intersection B. Now let us find out outcomes favorable to the event A. So P of A I have to find out outcomes favorable to the event A divided by total number of outcomes as per the definition of probability. What are the outcomes favorable to the event A? Multiple of 3. 3 and 6. So 2 divided by 6. P of B equal to prime number. Which are prime number among these? So it is, they are 2, 3 and 5. So totally there are 3 outcomes favorable to this event by total 6 outcomes. Now P of A intersection B I have to find out. What is A intersection B? Multiple of 3 as well as it is a prime number. Which outcomes will satisfy this condition? Multiple of 3 means 3, 6. Only 2 possibilities. Out of 3, 6, which is a prime number? 3 is a prime number. 6 is not a prime number. Therefore, only one outcome will satisfy. So, it is 1 by 6. Substitute all these here. So, you will get 2 by 6 plus 3 by 6 minus 1 by 6, which is equal to 5 minus 1, 4 by 6, which is equal to 2 by 3. So, probability of A union B equal to 2 by 3. This is how we use the concept of addition law or addition theorem. Similarly, one more problem. From a pack of 52 playing cards, one card is drawn at random. What is the probability that it is a jack of spade or queen of heart? So, or is there. You have to define two events first. Then you have to find out the union of those two events. Let us do that one by one. S is equal to, N of S is equal to 52, because one card is chosen. There are 52 possible ways in which you can choose one card out of 52 playing cards. Now event A is that is a jack of spade, getting a jack of type spade card. Then B is a queen of heart. So you know that in every type there is one jack, one queen and one king. So therefore totally there are how many cards in spade? 13 cards, 13 spade cards as well as 13 heart cards. Out of these 13 cards, here one jack will be there and here you will have one queen. Now you have to find out the probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. What is probability of A union B? Getting a jack of spade or queen of hearts. So that is A union B. So let us find out P of A. What is the probability of getting a jack of spade? How many outcomes will favor a jack of spade? So that is nothing but only one jack of spade will be there in those 13 cards, divided by what is the total number of possible outcomes? 52. So it is 1 by 52. I have just written here 13 cards. This 13 is of no use now. Just you have to consider the total number of outcomes and outcomes favorable to this event. There is only one jack of a spade. If it is just a jack, then there are 4 jacks in each type. But here they have mentioned is jack of a spade. Therefore, there is only one jack in spade. So, P of B equal to, again, queen of heart. So, it is again 1 divided by 52. What is A intersection B? A intersection B means it should be a jack of spade and queen of heart. At a time, the chosen card should be jack as well as queen, which is impossible. Whenever a card is chosen, it has only one identity. Either it should be a jack or it is some other card. But it can't be jack as well as queen at a time. So, this is P of A intersection B is equal to 0, because A intersection B is null set. They are mutually exclusive. They do not have any element in common. Therefore, this addition law becomes now P of A union B equal to P of A plus P of B, which is equal to 1 by 52 plus 1 by 52. This 2 by 52, 1 by 26. This is the required answer. Now about conditional probability. This conditional probability. I'll give you a simple example. Suppose your teacher has given you an assignment and she asks you to submit within this date. So definitely the number of submissions would be less or more, it depends on the class. So if you are finding the probability of getting the assignments done is equal to the obtained assignments divided by the total number of students, so you will have some probability. Suppose if a teacher restricts or gives a condition, if you don't give me the assignment, then your internal marks will be deducted. So in that case, what happens to the probability? Then based on that given restriction, there will be more number of assignments than the previous one. That may not be sure event, still that may not be sure event, because there might be some students who do not still submit the assignment. So it may not be a sure event, but compared to the previous one, there will be a change in the probability. It may be more, okay, divided by total number of students. So there will be a change in probability. So such probability is called as conditional probability. So if one event, this is event A, if this is another event B, so if one event affects the probability of another event, then we call it as a conditional probability. In simple words, this is the best example. It is denoted as P of A given that B has occurred. This is how we denote the conditional probability. In some restriction or some condition is given where the second event already occurs. If the second event occurs, then if it affects the probability of the first event, then we call it as conditional probability. Say in example of random experiment, suppose you have throwing a die 1, 2, 3, 4, 5, 6. This is the experiment of throwing a die and it is the sample space. Now I will give you an event A as getting prime number. So what is the probability of getting a prime number when a die is thrown? So prime numbers are 2, 3, 5. So which is 3 by 6, which is 1 by 2, around 50%. There is a 50% chance of getting an odd number. Now instead of this, I will mention a condition. I have thrown a die and I got an odd number. So odd number occurs. So in this case, will this affect the probability of the event A? That is P of A given that B has occurred. So I have thrown a die and I already got an odd number. You have to find out what is the probability of getting a prime number in this case. So if you have thrown a die and if you already got an odd number, so then what happens to the sample space now? It gets reduced. What are the odd numbers? Here 1, 3, 5. Now you have to find out the probability of getting a prime number. Out of these, now the prime numbers are 3 and 5, so it is 2 divided by 3. 2 by 3 means around 66%. Now chance of getting prime number increases when you compare this with the previous case. Here just one event is given, but here in the second case, what I have done is I have thrown a die and I already give you a condition that I obtained odd number. So now you find out the probability of getting a prime number. So therefore this event which already has occurred will affect the probability of the event A. Such probability is called as conditional probability, which is denoted as this. This is not read as divided by, it is P of A given that B has occurred. So this probability is called as conditional probability. Now what is the formula to obtain conditional probability? P of A given that B has occurred equal to P of A intersection B divided by P of B. So this is the formula to find out conditional probability, where P of B is not equal to 0. Means B should not be an impossible event. If B is an impossible event means what? That event will never occur. If such event is given, that will never affect the probability of any other given event. So that condition should be mentioned here, P of B not equal to 0, because an impossible event which will never occur, if the event only doesn't occur, that will never affect the probability of another event. Here what we are calculating is, if occurrence of one event, will it affect the probability of another event. We have seen here examples also. So this is the formula to calculate the conditional probability of given two events. What is multiplication law of probability? It is given by P of A intersection B equal to P of A into P of B given that A has occurred, or P of B into P of A given that B has occurred. If A is given, then you have to multiply it with P of A. Even given event is B, multiply with the probability of B. Same as we have defined for conditional probability, which is P of A given that B has occurred equal to P of A intersection B by P of B. So from this definition only, I can write P of A intersection B, P of A into P of B by A, or P of B into P of A by B. So this is called as multiplication law, because sometimes we can write A intersection B as just AB. So due to which we call it as a multiplication law. P of A B equal to P of A into P of B by A. So this law is called as multiplication law. What are independent events? See, I will take example of throwing a die. Sample space is this, and I will give you two events. A is getting a number less than 5 and B is getting an odd number. So what is the probability of A getting a number less than 5 is nothing but 1, 2, 3, 4. So it is 4 by 6, which is 2 by 3. What is the probability of B getting an odd number, which is 1, 3, 5, 3 by 6, which 1 by 2. Now, suppose if I have given you the condition throwing a die where event B has occurred. So, I have thrown a die and I got an odd number. So, you have to find out what is the probability of getting number less than 5 in that case. So, therefore, P of A given that B has occurred, which is equal to probability of getting a number less than 5 if an odd number has already occurred. So if an odd number has occurred, possibilities are 1, 3, 5. So sample space will reduce to this. What is the probability of getting a number less than 5? Out of these three outcomes, less than 5, two outcomes are favorable, divided by 3. 3 because there are 3 outcomes in the sample space now. So because sample space gets reduced due to this restriction. This is the sample space of throwing a die. This is the sample space of throwing a die and getting an odd number. So there are 3 outcomes in the sample space, out of which favorable to this event are 1 and 3. So 2 by 3. So now you compare. What is the probability of A? It was 2 by 3. Even after the occurrence of the event B, probability of A remains 2 by 3 itself. It is not changed. It remains same. So such events are called as independent events. If the occurrence of or non-occurrence of one event, if it does not affect the probability of another event, then we call those events as independent events. Therefore, what happens in the case of independent events? Probability of A given that B has occurred is same as P of A, or probability of B given that A has occurred is same as P of B. So in that case, the multiplication theorem becomes P of AB equal to P of A into, what is P of B by B given that A occurred, or A given that B occurred, which is same as P of B. Therefore, this is the condition for independent events. Two events A and B are said to be independent. if P of A be equal to P of A into P of B, or else we can say P of A intersection B equal to P of A into P of B, then we call those events as independent events. See, in this case, if you find out P of A into P of B, 2 by 3 into 1 by 2, so that gives you 1 by 3. What is the probability of P of A intersection B in this case? A intersection B means getting a number less than 5 and odd number at a time. So, what outcomes will satisfy that? Getting a number less than 5 and it should be an odd number means only two possibilities here, 1 and 3. So it is 2 by total 6, that gives 1 by 3. So probability of A intersection B is same as P of A into P of B. Hence the events are independent. So whenever if you are given with the two events, how will you check whether they are independent or not? You have to make use of this formula. Find P of A intersection B, then find P of A into P of B. If both are same, then the events are independent. Otherwise the events are not independent. Suppose if you have three events, then in that case P of A intersection B intersection C equal to P of A into P of B into P of C you have to get to say that those events are independent. Now, if A and B are independent events, if this is given to you, A and B are independent events, then A and B dash are independent, A dash and B are independent, then A dash and B dash are independent. This is a result. Whenever if two events are independent, then A and not event B, those two are also independent. That means you can write P of A intersection B dash as P of A into P of B dash using the definition of independence. P of A dash intersection B is also P of A dash into P of B. You can split like this. P of A dash intersection B dash is equal to P of A dash into P of B dash, because A and B are independent. If this is given, then these three also follow. A and B dash are independent, A dash and B are independent, A dash and B dash are also independent. And if A and B are mutually exclusive, then they can never be independent. Mutually exclusive, then A and B cannot be independent. So mutually exclusiveness and independent events are totally different. If they are mutually exclusive, then they can't be independent events. Now let us solve few problems to understand the concept. See the first problem. A die is thrown. If the outcome is a number greater than 3, what is the probability that it is a prime number? So if the outcome is number greater than 3, outcome is already given to you. Number greater than 3 means some event is given to you. It is the concept of conditional probability here. You have to find out what is the probability that it is a prime number. So how will you identify is it conditional probability or not? You have to read the question properly. Outcome is a number greater than 3. A die is rolled and this has happened, means some condition is given to you. So the event which has occurred, you take it as B. So number greater than 3. Event A, you take it as, you want to find out the probability of this event, you take it as A. So it is prime number. Now you have to find out probability of A given that B has occurred is how much. What is the formula? Probability of A given that B has occurred equal to P of A intersection B divided by P of B. If just you have to change the denominator based on which event has occurred. If B has occurred, then divided by P of B. If A has occurred, then divided by P of A. So now we want A intersection B. What is A intersection B? Number should be greater than 3 and it should be prime number. So which outcomes will satisfy this? Here number greater than 3 means 4, 5, 6. here A, favorable outcomes. Number great is a prime number, means 2, 3, 5. Now, out of these two, what is the common outcome? That is nothing but 5. Number greater than 3 and it should be a prime number, that is 5. Now, you find out the probability. What is the probability of A intersection B? One outcome favorable divided by total 6 outcomes, because you are rolling a die, divided by P of B is, yes, 3 outcomes favorable by 6. 6 cancels, which is equal to 1 by 3. This is how we find out the conditional probability. One more question. An urn contains 4 red and 7 blue balls. This is given. 2 balls are drawn one by one without replacement. Find the probability of getting 2 red balls. So this is the given question. First you have to understand on what concept this question is asked. It is asked on multiplication theorem. Multiplication law. That is because multiplication law says that P of A intersection B equal to P of A into P of B by A. Now you have to define the events A and B first. Then we have to find out A intersection B. So here it is 2 red balls. So you have to define 2 events. First drawn ball is red. First drawn ball is red and second drawn ball is red. So when you combine these two, A intersection B, what it is? First ball is red and second ball is also red. That means getting 2 red balls. We have to find out now P of A intersection B equal to P of A into P of B, given that A has occurred. Now you have to find out what is P of A and what is P of B, given that A has occurred. Now it is given without replacement. That means once you have drawn a ball, you are not putting that ball back into the box. Hence, for the next draw, the chances will be less. The total outcomes will be less. That's why P of B by A, it affects the probability of second draw. First draw will affect the probability of second draw, as we are not putting the ball into box back. So without replacement means it is always this conditional probability. With the replacement means then that conditional probability will change, because there is no change in the probability. Now let us find out P of A. What is the probability of getting first drawn ball is red. How many red balls are there? There are 4 possibilities divided by total number of balls 11. Now for the second drawn ball is red, given that first drawn ball is red. This event has occurred and without replacement. Therefore 1 red ball drawn means how many red balls left now? 3 divided by, and total number of balls also changes because we have not put that ball back into the box. So 7 plus 3, it is 10, 1 less than this. So now you have to substitute 4 by 11 into 3 by 10, which is equal to 6 by 55. This is the answer. See one more problem. If A and B are independent events, this is given. So P of A intersection B equal to P of A into P of B. This is by the definition of independent events. Now, if P of A equal to 0.4, P of B equal to 0.2, you have to find out all these values. The first one, what is that? P of A dash intersection. So if A and B are independent events, then you know that A dash and B are independent, A and B dash are independent, A dash and B dash are also independent. So I can write this as P of A dash into P of B. Only this splitting is possible if it is given as independent event, that they have already given. Though A dash and B are independent, not directly given, if A and B are independent, if this is given, automatically all these 3 will follow. So what is P of A dash? P of A is 0.4. So I have to find out P of A dash, that is 1 minus P of A into P of B. That is the formula of P of A dash, 1 minus P of B. So 1 minus 0.4 is 0.6 into P of B is 0.2, that is equal to 0.12. Now second question, probability of A intersection B dash is calculated as P of A into P of B dash, because A and B are independent means A and B dash are also independent. P of A is 0.4 into P of B dash is 1 minus P of B, that is 1 minus 0.2 is 0.8, that is 0.32. Now third question, P of A dash intersection B dash, which is equal to P of A dash into P of B dash, equal to P of A dash is 1 minus P of A, that is 0.6 into P of B dash is 1 minus P of B, 0.8, that is 0.48. Next, fourth question, you have to find out P of A union B. What is P of A union B? P of A plus P of B minus P of A intersection B. Now P of A is given 0.4 plus P of B is given as 0.2 minus, what is P of A intersection? That is not directly given, but A and B are independent means it is P of A into P of B, 0.4 into 0.2. Let us simplify this. 0.6 minus 0.08, which is equal to 0.6 minus 0.08, 0.52. So this is how we calculate P of A union B. It's P of A by B and P of B by A. So P of A by B equal to A by B in the sense is read as given that. So P of A intersection B divided by P of B, which is equal to P of A intersection B is nothing but 0.08 divided by, because A and B are independent, P of B is 0.2, 8 by 20 is equal to 2 by 5. Sixth one, P of B by A, same as before, P of A intersection B divided by P of A, so which is equal to 0.08 divided by 0.4 is equal to 8 by 40, that is 2 by 10, which is nothing but 1 by 5. Yes, all sub questions over. This is how we find out the individual probabilities when P of A, P of B given and A and B are independent. That condition is specified. Fourth problem. Two cards are drawn from a pack of cards in succession with the replacement of first card. Find the probability of both are heart cards. So, the first card is heart card. First card is heart card. And the second event B is second card is heart card. Now, what you have to find out is A intersection B. Both are heart cards. Both cards. You have to find out its probability. So P of A intersection B equal to P of A into P of B I will write, because these two events are independent. A and B are independent. Independent because here they have given in the question with the replacement. Therefore, the probability of occurrence of a first event will not change the probability of occurrence of second event. Means A and B are independent. If it was without replacement, then it is conditional probability. Now with the replacement means for the second case also, second draw also, you will have the same number of heart cards. So how many heart cards are there? 13 heart cards are there. So what is the probability of getting first card as heart card? So 13 divided by 52. 13 favorable outcomes divided by 52 total cards. Then P of B is also 13 divided by 52, because for the second draw also same number of favorable outcomes as we are replacing the first card once again. Hence you will get 13 by 52. So that is 1 by 4 here. This is also 1 by 4. So that is 1 by 4 into 1 by 4, which is equal to 1 by 16. This is the probability of getting both the cards as heart cards. One more problem. A class consists of 10 boys and 40 girls. 5 of the students are rich and 15 students are brilliant. Find the probability of selecting a brilliant rich boy. Here I will define 3 events. A is you have to select a brilliant rich boy. So event A is the student is brilliant, student and event B is student is rich, and event C is student is a boy, because you have to find out probability of selecting brilliant rich boy. So there are 3 events and all these 3 events are independent. A, B, C are independent. It's very clear. The probability of occurrence of one will not affect the probability of occurrence of another. So P of A intersection B intersection C equal to brilliant rich boy, that is P of A into P of B into P of C. What is the probability of a student is brilliant? There are how many brilliant students? 15 divided by total number of students 10 plus 40 50 into probability of student is rich. How many rich students? 5 are rich, so 5 divided by total number of students 50. How many boys in a class? 10 divided by 50, so which is equal to 3 by 10 into 1 by 10 into 1 by 5, so which gives you finally 3 by 500. So this is the probability of the selected student is brilliant, rich and boy. This is how we use the concept of multiplication theorem, conditional probability and independence of events to solve the problems. Now next is probability of happening at least one of the independent events. How to find out that? Probability of A union B. Here at least one of A and B is nothing but A union B, where A and B are independent events. This is given. So P of A union B is 1 minus P of A union B whole dash. This we already know. 1 minus P of A dash intersection B dash, that is by De Morgan's laws. So 1 minus P of A dash into P of B dash. We can split it like this because whenever A and B are independent events, A dash and B dash are also independent event. Therefore 1 minus, this is nothing but probability of happening none of the events. So probability of happening at least one of the independent events is equal to 1 minus probability of happening none of the events. This is the formula. See one example for this. A person is known to hit the target in 4 out of 5 shots, whereas another person is known to hit 2 out of 3 shots. Find the probability that the target being hit when they both try. We have to find out probability of target being hit. This probability we have to find out. When the target is being hit, if at least one of the person hits the target, either the first person hits the target, then target is hit, or second person hits the target, then target is hit, or both may hit the target. In that case also the target is hit. Therefore we have to find out probability that at least one of them, one of the person hits the target. So that is nothing but probability of A union B. A means first person hits the target, B means second person hits the target. So what is the formula as per this? 1 minus probability of A dash into probability of B dash. That is because this is 1 minus P of A union B whole dash, as A union B whole dash is A dash intersection B dash, and A and B are independent events. Here they hit the target independently, so they do not affect each other. The events do not affect each other, therefore they are independent events. So you will get 1 minus, what is the probability of A hitting the target? It is given as 4 out of 5, so 4 by 5. What is the probability of B hitting the target? That is given as 2 out of 3 shots. So 2 by 3. Hence you will get P of A dash. P of A is 4 by 5. P of A dash is 1 minus 4 by 5, which is 1 by 5. Into P of B is 2 by 3. P of B dash is 1 minus 2 by 3, that is 1 by 3. So you will get 1 minus 1 by 15, that is equal to 14 by 15. This is the probability of target being hit, which is nothing but at least one of the person hits the target. That is, either A hits the target or B hits the target, or A and B both hits the target. Next is about problems using both addition and multiplication laws. We know what is addition law and what is multiplication law. We will combine both to solve problems related to probability. See the first one. Person A and B appear in an interview for 2 vacancies for the same post. The probabilities of A's and B's selection are 2 by 5 and 1 by 5 respectively. Find the probability that exactly one of them is selected. So first I will take event A as A is selected. I will take the event B as B is selected. Now probability of A is equal to 2 by 5 given. Probability of B equal to 1 by 5. This is already given in the question. And these two A and B are independent events. Clearly they are independent, because they have to attend the interviews independently. So these two are independent events. Now you have to find out, first question, exactly one of them is selected. What is the probability of exactly one of them selected? So exactly one of them is selected means A is selected and B is not selected. Then only it is exactly one. So A is selected and means intersection. B is not selected means B dash. Or A is not selected, so A dash intersection B is selected. So how to find this? Now P of A intersection B dash, or means plus P of A dash intersection B, because here or means actually it is union. Union means using the addition law. So we can split it like this. Or means it is union. Then using addition law, P of A plus P of B. They are the independent events. Whenever A and B are independent, A, B dash, A dash, B, A dash, B dash are also independent. Now you apply the multiplication law. That is P of A into P of B dash plus P of A dash into P of B, using the multiplication law. This step is using addition law. Then this step is using multiplication law. Then P of A you substitute 2 by 5. What is P of B dash? 1 minus 1 by 5, which is 4 by 5, plus P of A dash is 1 minus 2 by 5 is 3 by 5 into P of B is 4 by 5. So this gives you 4 to the 8 by 25 plus 12 by 25, which is equal to 20 by 25, which 4 by 5. Second question, at least one of them is selected. At least one of them means either A is selected or B is selected or both A and B selected. So I will second question, at least one of them is selected means probability of A union B. You know that at least one or union P of A plus P of B minus P of A intersection B, as per the formula. P of A is 2 by 5 plus 1 by 5 minus, how to find P of A intersection B? As A and B are independent, P of A intersection B is P of A into P of B, which is 2 by 5 into 1 by 5. So this gives you 2 by 5 plus 1 by 5 minus 2 by 25. So this is equal to 10 plus 5 minus 2 by 25 is equal to 13 by 25. This is the probability. Third one, none is selected. Probability of none is selected, which is P of A is not selected means A dash occurs. and B is not selected, B dash occurs, which is nothing but P of A union B whole dash, which is equal to 1 minus P of A union B, that is equal to 1 minus 13 by 25, that is 12 by 25. This is how we calculate the probability using addition and multiplication together. Next question. Two cards are drawn from a pack of 52 cards with the replacement. What is the probability that both drawn cards are of the same suit, means same type? So there are totally 4 types: heart, club, spade and diamond, and in each type there are 13 cards. So I have to define now totally 4 events, that is A, B, C, D, 4 events, or you can say A1, B1, C1. The first card is heart, first card is spade, first card is club, first card is diamond. Next 2 cards drawn, so A2, B2, C2, D2. Here second card is same, heart, second card is spade, second card is club, second card is diamond. So now I have to find out both cards are of the same suit. So both cards of same possibilities you have to write. Both cards can be heart, or both cards can be spade, both cards can be club, both cards can be diamond. So it is A1 intersection A2 or union, then B1 intersection B2 because spade, union C1 intersection B2 union D1 intersection B2. Then you have to apply addition law, that is P of A1 intersection A2 plus P of B1 intersection B2 plus P of C1 intersection C2 plus P of D1 in D2. Next equal to, now multiplication law. Each event is independent. It is given that with the replacement. So each event is independent. So P of A1 into P of A2 plus P of B1 into P of B2 plus similarly P of C1 into plus P of D1 into P of D2. So what is the probability of first card drawn is heart? How many heart cards? 13 divided by total number of cards 52 into second drawn card is also heart. This with the replacement, again 13 cards available and total 52. Here also same, 13 by 52 into 13 by 52 plus 13 by 52 into 13 by 52. So that gives you 13 by 52 is nothing but 1 by 4. So 4 times 1 by 4 into 1 by 4, because there are 4 terms. The same will continue here. So it is equal to 1 by 4. The probability is 1 by 4. So this is how we use the addition law and multiplication law to find the probability of given event.